we are one step closer to answering the age-old question, are we alone in the universe?
We want to look maybe even for radio transmissions. Perhaps there's intelligent life there. Perhaps they've harnessed some kind of radio.
Astronomers just found something incredible. A spinning disk around a star in a galaxy 160,000 light-years away called the Large Magellanic Cloud. This isn't your everyday find. It's the first time we've spotted such a thing outside our galactic neighborhood. This revelation isn't merely significant. It represents a significant advancement into unexplored cosmic realms. What secrets does this distant disk hold? How does its presence in a foreign galaxy challenge our understanding of stellar formation? Now let's explore how astronomers spot a disk orbiting a star in another galaxy for the first time. The game-changing discovery of HH 1177. Recently, an incredible discovery unfolded in the vastness of space. Astronomers spotted a young star not in our own Milky Way galaxy, but in a neighboring one called the Large Magellanic Cloud. This star, named HH 1177, is surrounded by a dense, swirling disk, which might be where new planets are born. It's like a cosmic nursery. This discovery is a big deal because it helps us understand better how stars and planets form. When stars are young, they go through a growth spurt by pulling in matter from nearby. This matter, made of gas and dust, gathers around the star in a flat disk called an accretion disk. This happens because the star's gravity is strong. As this disk spins, it brings more material to the growing star, making it bigger bit by bit. How heavy the star is affects how strong its gravity is, which then pulls in even more gas and dust into the disk around it. This whole process is essential in creating stars and planets. HH 1177 is part of a group of huge stars that live fast and don't stick around for long in cosmic terms. They evolve much faster than stars like our Sun, so their lives are just a tiny blip compared to the usual star's lifespan. Because they move so quickly through their life stages, it's tough to catch them in their early years right here in our galaxy. The dusty stuff surrounding these stars where they're born makes it hard to see both the star and its disk. But the place where stars like HH 1177 are born in the Large Magellanic Cloud is different from where they're born in our Milky Way. HH 1177 hangs out in a stellar nursery called N180, where there's not as much dust and the amount of certain elements, called metals, is lower. That means this star isn't covered by as much gas and dust as others, so we can see it from far away without anything blocking our view. It's like getting a clear but distant look at how this star is made and how it's shaping up. Dr. Anna McLeod, the head researcher leading this incredible discovery and an associate professor of physics at Durham University in the United Kingdom, was stunned by what she and her team found in the data collected by the Atacama Large Millimeter or Submillimeter Array of telescopes in Chile. Her excitement mirrored just how important it was to detect the first ever accretion disk outside our galaxy, a moment that's a game-changer in exploring the cosmos. She stressed how crucial these disks are in creating stars and planets in our own Milky Way, and emphasized how mind-blowing it was to see direct proof of this happening in a galaxy so far away. This discovery of HH 1177 was all thanks to the incredible power of the ALMA telescopes. The results, which are a big deal in the world of astrophysics, were shared in a prestigious journal called Nature, marking a significant milestone in our understanding of the universe. But how does it contribute to our knowledge of stellar evolution? Well, let's get into that. Decrypting HH 1177's accretion disk dynamics. You see, the discovery of HH 1177's accretion disk wasn't a lone success story. It followed an important find made possible by the European Southern Observatory's Very Large Telescope. The multi-unit spectroscopic explorer tool, attached to the telescope, played a crucial role in this earlier discovery. Muse captured a stunning stream of material shooting out from the young star, HH 1177, hidden deep within a gas cloud in the galaxy. Dr. Anna McLeod, the lead researcher, emphasized how this find was a big deal, explaining that the observed stream was a clear sign of a disk forming around the massive young star. This discovery not only adds to what we know about space, but also deepens our understanding of how stars form in their early stages. Later on, the ALMA observations aimed to dig deeper into HH 1177's accretion disk. The scientific team used a method that measured how quickly dense gas moved near the star to figure out if there was indeed a disk around it. When material heads toward a young star, it doesn't just go straight to the star's surface. Instead, it flattens and swirls around, forming a disk. Importantly, this disk spins at different speeds, with the center spinning faster. This difference in speeds gives astronomers a vital clue to confirm the presence of a disk around a star. Dr. Jonathan Henshaw, a researcher from Liverpool, John Moores University in the UK, and a co-author of the study, explained the complexities of this measurement technique. He likened it to how the sound of an ambulance changes as it speeds by, a comparison that helps understand how the light's frequency changes depending on the speed of the gas emitting it, whether it's moving closer or farther away. This detailed approach let the team measure the spin of the accretion disk, giving us important insights into how stars form. But there is more. The significance of the discovery. This discovery isn't just another cosmic tick on a checklist. It's a massive leap forward in our understanding of how the universe works. Imagine if you'd only ever seen one type of tree in your life. You know everything about it, how it grows, what it needs, and how it fits into its environment. Now, picture stumbling upon a completely different tree species, growing in soil and weather you've never seen before. It's like stepping into a whole new world of knowledge and understanding. For astronomers, discovering how planets form in the Milky Way compared to the Large Magellanic Cloud feels just as transformative. It's like unlocking a whole new set of secrets. The LMC is like a second lab for scientists. It's a chance to test and improve our theories. By comparing how planets form in these two galaxies, we can spot patterns, find things that don't quite fit, and get better at understanding how planets are born. It's like getting a fresh perspective that makes us smarter about the universe. Let's talk about visibility, a big advantage in the LMC. There's less stuff in the way, like fewer metals and dust, so we can see stars there better using regular telescopes. That's a huge plus, because it lets us study these cosmic happenings in clear detail. It's like going from a blurry black and white photo to a clear, colorful image. Being able to see things so clearly helps astronomers spot things they couldn't see before and understand parts of planet formation that were hard to figure out. Watching how planets form in a different galaxy than our own expands our understanding of the universe. It reminds us that we're just a tiny part of something vast and endlessly fascinating. This discovery shows that our exploration journey is far from done. It tells us there's so much more to learn, tons of mysteries waiting to be solved, and countless worlds out there waiting to be found. Now, let's explore the origins of ALMA and its groundbreaking discoveries. The collaborative journey of ALMA. ALMA, short for the Atacama Large Millimeter Submillimeter Array, emerged from the convergence of three key astronomical endeavors: the Millimeter Array in the United States, the Large Southern Array in Europe, and the Large Millimeter Array in Japan. These initiatives laid the groundwork for what would evolve into one of the most significant astronomical observatories globally. The project's inception dates back to 1997, when the National Radio Astronomy Observatory and the European Southern Observatory allied to merge their respective MMA and LSA projects. This merger aimed to amalgamate the sensitivity of the LSA with the frequency coverage and prime location of the MMA. Collaborative efforts between ESO and NRAO, alongside Canada and later Spain's involvement, culminated in the formation of a joint project. Numerous resolutions and agreements paved the path for the birth of ALMA. In March 1999, Atacama Large Millimeter Array was chosen as the project's name. Notably, the name ALMA bears significance, translating to soul in Spanish and signifying learned or knowledgeable in Arabic. Formalizing the endeavor, the ALMA agreement was signed in February 2003 between North American and European parties, marking a crucial milestone in its development. Japan's participation expanded ALMA's scope when the National Astronomical Observatory of Japan proposed the addition of the Atacama Compact Array and 3 supplementary receiver bands. Following extensive discussions, Japan officially became a participant in enhanced ALMA, leading to the renaming of the project as the Atacama Large Millimeter Submillimeter Array. The project's groundbreaking ceremony took place on November 6, 2003, accompanied by the unveiling of the distinctive ALMA logo, symbolizing its visionary pursuit. Early planning stages emphasized collaboration among renowned companies in North America, Europe, and Japan for the construction of ALMA's antennae. This decision, driven primarily by political considerations, sought to integrate diverse antenna designs capable of meeting ALMA's rigorous specifications. The logistical intricacies involved in this global collaboration were immense. Specifically, 26 antenna components crafted across Europe were meticulously transported by the Route to Space Alliance, a specialized aerospace logistics company. These components were routed through Antwerp before their final journey to Chile, signifying the extensive international cooperation vital to ALMA's realization. ALMA, initially established through a joint effort between the National Radio Astronomy Observatory and the European Southern Observatory, expanded its consortium to include Japanese, Taiwanese, and Chilean partners. This collaboration birthed the most ambitious ground-based astronomical project, with a price tag ranging between US $1.4 and $1.5 billion, a monumental investment that ranks it among the costliest ventures in astronomy, although surpassed by certain space-based initiatives like the Hubble Space Telescope and the James Webb Space Telescope. But that's not all. Early revelations of cosmic mysteries. By the summer of 2011, ALMA reached a pivotal milestone with a fleet of operational telescopes, marking the commencement of extensive testing before entering the early science phase. These initial observations provided a tantalizing glimpse into the array's potential, foreshadowing superior image quality as the array continued to expand. One of ALMA's early triumphs lay in capturing the antennae galaxies, showcasing sub-millimeter wavelength images revealing dense, cold gas clouds, a phenomenon imperceptible through visible light. Despite not observing the entire galaxy merger, these images marked a milestone in unveiling the elusive regions where new stars take shape. In August 2014, ALMA made headlines by unveiling intricate details within the coma of comets C2012 F6 and C2012 S1, shedding light on the distribution of compounds like hydrogen cyanide, hydrogen isocyanide, formaldehyde, and dust within these celestial bodies. Another breakthrough came with the revelation of a protoplanetary disk enveloping HL Tauri, a youthful T Tauri star. The image, released in 2014, showcased concentric rings and gaps within the disk, challenging existing theories by suggesting planetary formation in a remarkably young system. This discovery fueled new speculations, with one theory attributing the accelerated accretion rate to the intricate magnetic field of the protoplanetary disk. ALMA played a pivotal role in the Event Horizon Telescope project, culminating in the historic 2019 release of the first direct image of a black hole, an astronomical feat that reverberated across scientific communities worldwide. Additionally, ALMA contributed to a groundbreaking study on Venus, initially detecting phosphine, a potential biomarker, in the planet's atmosphere. This finding stirred controversy and debate within the scientific community, prompting reanalyses and subsequent confirmations, yet the ultimate implications regarding biological organisms on Venus remain a subject of ongoing exploration, pending further measurements and study. The recent discovery of a planet-forming disk around a star in the Large Magellanic Cloud is a big step for space exploration. Astronomers are getting ready to study it with the James Webb Space Telescope. This telescope has already found an exoplanet and is set to reveal new insights into this extragalactic disk. With its advanced technology, the telescope will show us the composition, structure, and dynamics of the disk. Exciting discoveries are expected. This finding not only shows our technological skills, but also guides us toward new knowledge. It introduces possibilities for understanding how planets form. Comparing the processes in our Milky Way with those in the Large Magellanic Cloud may reveal new phenomena. The discovery highlights the vastness and diversity of the universe. A planet-forming disk around a star in a galaxy 160,000 light-years away reminds us that our understanding of the universe is just starting, with many mysteries to unravel. Let us know what you think about this recent discovery in the comments below. And for more of the latest developments in space, make sure to subscribe to the channel.